Hey guys, this is Miss Bess. I am making this video for you. Before you get started, you need to make sure that you have a few sheets of paper and pencil so that you can copy the notes down as I go through the video. All right, so I'm going to go ahead and get started. This video is on simplifying square roots. And if you read the quadratic brief, you'll know that we use square roots as a method to solve quadratic equations. But before you can solve the equation, you need to know a little bit something about square roots. So first of all, a square root is a number r, which could be any number, um, is a square root of a number s if r squared equals s. Okay, so that's to say like um, 2 is the square root of 4 because 2 times 2 is 4. And then also a positive number always has two square roots. For example, here we have the square root of 16. The square root of 16 is 4 because 4 times 4 equals 16. The square root of 16 could also be negative 4 because negative 4 times negative 4 is 16. Okay, so the square root of 16 is a positive 4 and a negative 4. And we show that by using a symbol called a plus or minus. Um, so the square root of 16 equals plus or minus 4 because it could be positive 4 or negative 4. If I go too fast, remember this is a video. You can pause it or rewind it. I'm just trying not to make this extra long for you guys. Next, we're going to talk about some parts of a square root. A square root has a radical sign. That's this symbol here. And then there's a radicand. That's the number that's underneath the square root. Okay, so in this case, our radicand would be 16. There's two properties that we use to simplify square roots. They're called the product property and the quotient property. Product, of course, means to multiply. So the product property shows if you have the square root of two numbers multiplying, for instance, a times b, you can break them up into the square root of a times the square root of b. And that allows you to do some things. It helps you simplify the square root. So we're going to show you an example of that later. And then the quotient property basically says the same thing, but with division. So if you have the square root of a fraction or two numbers dividing, you can break them up into the square root of a over the square root of b. All right. Next, one method of simplifying square roots is called prime factorization. And some of you may remember this from Math 1 or middle school. If you do, then you can use this method if you like, and help your classmates if they would also like to use this method. So prime factorization is basically finding the factors of a number that are all prime. So you just keep breaking down that number until you have all prime numbers left. And a prime number is a number that's only divisible by itself in 1. So for instance, the square root of 24, hold on, sorry. Oh, well, that's okay. The square root of 24, we can break that down to the square root of 4 times the square root of 6 using the product property. And then, using the product property. And then since neither 4 nor 6 are prime numbers, we have to keep going, okay, until we break them all down to prime numbers. So 4 breaks down to 2 times 2, 6 breaks down to 2 times 3, and then you'll see that you have a pair of 2's here. For each pair of numbers, that represents a root, and it should come out from underneath the radical. So since there's a pair of 2's here, we're going to bring 1 2 out to represent that root. And then all we have left is 2 times 3, no pairs, so it goes back to 6. So your final answer would be 2 square root of 6. Here's another example using prime factorization. We have the square root of 90. We break it down to the square root of 9 times 10. Still no prime, so we have to keep going. 9 breaks down to 3 times 3. 10 breaks down to 2 times 5. So now we have a pair of 3s. One of the 3s come out to represent the root. 2 times 5 stays underneath and becomes 10 again. So your final answer is 3 square root of 10. All right, so now I have a you try here for you guys. If you want to try this independently, go ahead and pause the video and try and do the square root of 48. Okay, so the square root of 48, I broke it down to 4 times 12. You could break it down to 6 times 8 or 16 times 3. It doesn't matter because as long as you break it down to the prime factors, you're going to end up with the same numbers. So I broke it down to 4 times 12. Then I kept breaking down the 4 and the 12. So 4 became 2 times 2. 12 became 2 times 6. Break it down some more. The 6 became 2 times 3. And now I see I have 2 pairs of 2's. Okay, so each 2 is going to come out because it represents a root. And when they come out, they multiply, okay, to make 2 times 2, which is 4. And then your final answer will be 4 square root of 3. Okay. Now, I'm also going to show you guys how to simplify using the calculator by watching this video here. I'm going to let him go through one example and then I'm going to link this video so you guys can watch it some more with him. But this is a quick and easy way to simplify square roots as well. All right, so you guys just saw him walk through that process of simplifying with the calculator. I also gave you a little printout that you can follow if you like to do the calculator method. Um, it says like simplifying radicals with the calculator, so you are more than welcome to use that method. Next, I want to tell you guys that not all square roots can be reduced. Sometimes it's just what it is. Like for example, the square root of 7. 7 is a prime number. You can't break it down any more than just 7 times 1, so it would stay the square root of 7. Square root of 10. 10 is not a prime number, but it only has prime factors with no pairs, so it's going to stay the square root of 10. Next we have another example where we have the square root of a fraction, square root of 7 over 16. So using the quotient property, we're going to break this up into the square root of 7 over the square root of 16. And then that allows you to take the root of each number separately. So the square root of 16 becomes 4. And then your final answer is just the square root of 7 over 4. Here's another one. We have the square root of 7 over 2. Now, we can break that up to the square root of 7 over the square root of 2, but neither one can be reduced because they're both prime numbers. But you cannot leave a radical in the denominator. Okay? That's one of the rules with square root. So we have to do what's called rationalizing the denominator, which pretty much just means getting the radical from underneath, from getting the radical out of the denominator. So the way you do that is you multiply the entire fraction, meaning the numerator and the denominator, by the denominator. So here, our denominator is the square root of 2. So we're going to multiply everything by the square root of 2. So now the top portion becomes the square root of 7 times 2 over the square root of 2 times 2. Now the square root of 7 times 2 is the square root of 14, and that can't be reduced anymore, so that's going to remain the square root of 14. Now when I multiply square root of 2 times square root of 2, I'm going to end up with just 2 because I end up having a pair, and this represents one root. So my final answer is square root of 14 over 2. I want you guys to remember that you only need to rationalize when you have a radical in the denominator. If there's no radical in the denominator, if you simplify all the way through, then you do not need to rationalize. All right, here's one more example. Square root of 144 over 11. We break it up using the quotient property, but there is a radical in our denominator, square root of 11. It can't be reduced anymore, so we have to rationalize. So we're going to multiply the top and the bottom by square root of 11. And then we have 144 times 11 over square root of 11 times 11. And I'm going to keep breaking down the numerator because I know it has 144 has factors in it. 144 is 12 times 12. It's a perfect square. So I can just circle these two. I don't have to keep factoring. I can just circle these two and a 12 comes out and I have square root of 11 over 11. Okay. Here is another you try. So you guys can pause the video here and try to work that out on your own. Okay, so once you break it down, you have square root of 13 in the denominator, so you have to rationalize. So multiply everything by the square root of 13. Okay, I ended up having a pair of 13s on the bottom, so I have a root of 13 here. I broke down 18 to 9 times 2. Break it down again, 3 times 3 times 2 times 13. I have a pair of 3's, so they're going to come out. 2 and 13 are prime numbers. I can't factor them anymore, so they're going to stay underneath. And I end up with 3 square root of 26 over 13. All right, so make sure that you get all of your notes down. Go back and rewatch the video if you need to. I will be doing a Google Meetup on Wednesday. I'm going to share the link on Google Classroom. So if you guys have any questions about this or any other assignment, then gather them all up and we'll try to talk about them on Wednesday. If anything changes, I will let you guys know. All right. Bye, guys.